Hello everyone, let's solve a problem from GATE 2011 Aerospace Engineering paper question number 32. The question is, consider the matrix 2a, b, 2 where a and b are real numbers. The two eigenvalues of this matrix lambda 1 and lambda 2 are real and distinct and such that both the lambda 1 and lambda 2 are not equal when when this scenario will happen. So that's what we have to find. Okay, these two are real numbers and we have to find the first find the roots, and we'll get a scenario where we have to check at which condition we will get a real and distinct roots, two different roots which are not complex number and which are not equal as well, right? So let's go and solve the problem. So the equation, the matrix that's been given to us is matrix A. Let's say matrix A is 2a, b and 2. Right? So in order to find the eigenvalues, so we have to take the determinant of a minus lambda I equal to 0. Right? So then we will get 2 minus lambda a, sorry, a, b, 2 minus lambda equal to 0, right? So then we will get 2 minus lambda whole square minus ab equal to 0. So 2 minus lambda whole square will become 4 minus plus lambda square minus 4 lambda minus ab equal to 0. Okay, here we get lambda square minus 4 lambda plus the constant term is 4 minus ab. Okay. This we have to find the lambda. So this part is like b square minus plus or minus root of b square minus 4ac by 2a. Okay, so here our a is the coefficient of lambda square, right, which is 1, right, which is 1 in this case. Our b is the coefficient of right, we have minus b here, so b is the coefficient of lambda, which is minus 4. Our c is the coefficient, constant coefficient, 4 minus ab. So let's just substitute here minus of minus 4 plus or minus root of b square is minus 4, then we will get 16 minus 4 into a is 1 and c is 4 minus ab, right? So and then the denominator 2 into 1. So in the lambda that we will get is minus of minus 4 is plus 4 plus or minus root of 16 minus, so we'll have 4 into 4 minus 16, and minus and minus will get plus, and we'll have 4ab plus 4ab, right, by 2. Then again we'll get 4, this 16 and 16 will get cancelled, we'll get 4 plus or minus 4ab 2, right? So if we just take 2 outside from the numerator, so 2 plus or minus root of ab, right? Here we are just taking a root of 4 is 2, so that 2 is taken outside here, so we will end up with root of ab, right? This 2 will get cancelled and the lambda will be 2 plus or minus root of ab. So this is what we are getting. Now we have to check at which scenario of a and b we will get real and distinct roots, right? So if let's consider one scenario where both a and b are 0, okay, which means what we will get, lambda will only one root we will get. So we will have two roots which are not equal, right? So this scenario is wrong. Okay, our next root either one is positive, one is negative. Okay, so then what it will become, so the inside plus inside the root we will get a minus, then we will get end up with a complex roots. Okay, so one of A and B becoming negative is also not a correct option, right? And neither A nor B is 0 is also not a correct solution, right? So let's go to the option. So this is not the correct solution, and one is positive, one is negative is not a correct solution, and one is positive and one is negative is not a correct solution. So the only correct option would be A is less than 0, B is less than 0. Then we will get A is less than 0, B is less than 0, and if both are negative or even if both are positive, we will end up with a positive value, and root of that positive value will give us a positive value. Then we will get two different lambdas, two different eigenvalues. So those will be real and distinct, right? So option C is the correct answer for this solution for this question. So if you want to know more about eigenvalues and eigenvectors, you can refer to the NPTEL course Engineering Mathematics 1 by Professor Jitendra Kumar from IIT Kharagpur. The particular lecture that you want to have a look at for this question is eigenvalues and eigenvectors, which is lecture number 46, and you can also see the YouTube link for that particular lecture here. So that's all for this question. Thank you.